This washroom chase is really, it's like there should be some medal for it. Just one card and two. Okay. Where did we stop in the last class? Why boys are only 2 of you? 3 boys absent, and we have only 5 of them.
3 of them are absent.
And 3 are absent. Chalo. So big responsibility, huh? Both of you today. Okay. Why are they absent?
Sir, one boy has fever, Sohan. He has fever and vomiting. The other boy, Anshul, he fell down yesterday. So there's a crack in his backbone.
Backbone or rib?
Backbone. Behind, he fell like this, I guess.
Oh, like, was he doing something?
He got slipped. It was raining yesterday. So he slipped because he was wearing slippers.
Okay. Where? On hard surface?
Yeah, on the floor. Tile, near the gate.
This?
Yes. Yeah. He came for class yesterday, but then later 10:15 he went down because it was too much.
Short?
No, the tallest.
The tallest one.
The tallest. He came for the class, but then he left because it was a lot of.
So where is he? He is hospitalized. Or
for 5-6 days he won't come.
But he is okay, huh? Like it's no bone fracture or just a sprain. Nobody knows.
I think that he can't get up.
Okay. What about the last boy? He is with them only or? No idea.
No, German. He's learning.
Germany. The smallest one.
No. No. He is learning German.
So he is learning German. So he has a German class today.
Yeah.
Which is blessing with physics. How can he learn language over? Alright. So what did we cover in ray diagram is completed? Okay. So we have power of lens. So we have sign conventions, lens formula, right? So the difference between convex and concave lens I am not doing, okay? These you can read and do, right? Then difference between real and virtual images, same like mirror, so you are already familiar. Okay, anybody needs any help in the difference between convex, concave lens? So if you read that, it is given in your book in the tabular form as well as in the notes. If you read, you should understand it. Okay. Next is sign convention and lens formula. So the notes are little out of sequence. Okay. Limitation of I. What is it? We will do that. No. So we'll visit at the end, right? Or shall we do it like this? ठीक है चलो. Well, let's start with power of lens. So anybody has any questions in ray diagrams? Pretty simple, very repetitive, right? We covered for all the lenses, convex as well as concave. Okay. So let's start with power of lens. So power of lens is its ability to converge or diverge your incident rays, right? So its bending ability. It is the ability of the lens to converge or diverge. That is bend. Both converging and diverging is bending, right? That is bend the incident ray. So more converging or more diverging means lens is more powerful. Okay. So now, so I am giving you two examples here. There is a thick lens and you have a thin lens, right? So let us say this is the incident ray. Okay, where will it bend it? At its focus. Right? So focal length is this much. Let's say this is F1. So it's whose focal length will be bigger, or thicker or thinner? Focal length is half the radius of curvature. Whose radius is bigger, this one or this lens?
That one.
Huh? Radius bigger.
Radius.
Bigger. So, and we have a whose surface is more curved, this or this?
That one.
This is more curved. So more curved surface radius is shorter, right? So you have, this is R2. If I only look at this much distance, where the curvature is more? Here or here? Curvature, curved surface, where is it more? Here. So for a more curved surface, the radius is shorter, right? Shorter. Which means focus will be even shorter. Half of
so
it.
It's the first case.
First case is shorter focus, right? So here the focus should be bigger. At a larger distance than this, correct? Because its curvature is less. Okay. Now this will be. Okay, so what is the focal length? You have F2 as well. There the bending is more with respect to the incident ray. Where is the deviation more? 1 or 2?
1 to 1.
Which has more power?
2. Bending is more into.
Bending is more into or less into?
No,
Which
it's
deviation
less
is?
into. It's
Okay. So it's less into. So this is less powerful because it is bending less. Correct? You understand? So it's a bit tricky. So where the focal length is less means the bending is more. That's why it is converging nearer. So thick lens is more powerful than a thin lens because its bending ability is more. Likewise, if any lens diverges more, it will be more powerful than a lens which diverges less. Got it? So more power, less focal length. That's why power of a lens is defined as reciprocal of focal length. Okay? Less denominator, more power, right? Got it? So therefore, power of lens is defined as reciprocal of focal length. Its focal length. Okay? So this is the formula for power of lens. Right? What is its unit? Unit is diopter. When focal length is measured in meter. Okay? Focal length, when it is measured in meter, then the unit of power is diopter. Okay? So the symbol is D. Okay? What is the sign convention? It will have the sign of the focal length. So for convex lens, what is the focal length? Positive or negative? Focal length is convex lens. How do you define the focal length? Where the parallel rays converge. Positive on the right side. Okay? So focal length is for convex lens, power is positive. You must have done sign convention for mirrors, right? Same sign. Front of the mirror, all the distances will be measured from pole. It will be negative. Anything on the left is negative. Anything on the right is positive. Anything above principal axis, positive. Below principal axis, negative. Same. Cartesian sign convention. So for convex lens, the focal length is on the right side. And for diverging lens, it is on the left side. So likewise, so for concave lens is also called diverging lens. Power is because its focal length is negative. Let me write since focal length positive, hence focal length. So the sign of power is derived from its focus. Is that clear? So this is like a concept diagram. You may skip it if you have understood. Or if you want, you can draw it in the margins. right? Almost. Okay, and then you say the power is 1 lakh. So net power. So combination of lenses. P is equal to so if you have more than one lens together, the net power of combination of lenses will be just addition of their respective powers. Right. That is so on and so forth. Next,
first diagram we can write wider lens, right?
Thicker.
Thicker lens.
Which lens has more power, thicker or thinner?
Thicker.
Why?
Thicker lens because the radius of curvature is less.
You say focal length. Focal length is short.
Length.
It has a short focal length as compared to thinner lens. Okay. Okay. Okay, shall we proceed? Now, we have to discuss the limitations of the eye, right? So, you must have observed. Is everybody finished? Done writing? Correct. Okay. So all of you must have observed that when the object is far away from us, it appears smaller, right? Like stars appear like dots, but they might be bigger than our planet in reality, right? So all far away objects look shorter to us. Why they appear shorter? Because how objects look bigger or shorter, it depends on the angle that they make with our eye. Right? So it depends on the visual angle made by the object. So what is the type of eye lens? Concave or convex?
Convex. Convex.
Decide. This is how the eye lens is, okay?
Convex.
Convex, right? It is convex. And the image is made on retina. Okay. This is the part of eye, let us say. So if the object is far away, right? So let us say object is, this is AB. Okay. So how will be the so one is very parallel to principal axis. Where will be the image found? At the retina, right? Let us say it will converge at retina. Now all the rays will have to take parallel only, right? It's far away. So I messed up. Wait. I want the image to be forming on retina. Retina is not just one point, it's somewhere here. Okay. So it will pass through wherever, and this will make the image at. Okay. So it appears, let us say, on this side. Now, when the object comes nearer, let us say nearer to it, how will it look like? Let me draw first this diagram. Right? Okay. And the straight one will now converge on the retina like this. So which is bigger? This or this? Huh? The red one, right? When the object is nearer, it appears bigger to the eye, right? So what determines it? The angle. This angle. Let us say this is theta 2 and this is theta 1. This is just for your explanation, understanding, okay? So theta 2 is greater than theta 1. So what is theta? Visual angle. So whenever the object, the same size, object size is not changing, it remains AB only. But now it appears bigger to the eye because of the angle which it makes with the eye principal axis. Okay? So the visual angle here, visual angle is bigger. This description is not in ICAC, right? It's in NCR. The visual angle is, or some other book, visual angle is bigger. The object appears bigger. Because there is no change in the size of the object, just it is difference in the visual angle. Because when it comes closer, the visual angle increases and the object appears bigger to us. But we are discussing limitation of eye. What is limitation of eye? See, sometimes the fonts written are very small. I am able to see whiteboard. This is visible to me. But this is not visible. So I'll try to bring it close. Now I can read. Okay. So does that mean if the object is so small, you can just go on bringing it closer and you will see it? No. You will realize there is a limitation to the nearest distance up to which I can see clearly. This is 25 centimeters. Okay, any normal eye cannot see the object clearly when it is brought closer to 25 centimeters. So you don't bring the mirror very close, right? At a distance only you see it clearly, right? Do you just go and stick yourself in the mirror? No, right? You go back, isn't it? It's because of this. So, for a normal eye, the least distance of distinct vision, that is the distance of distinct vision, or just D. Now this is not diopter. This is least distance of distinct vision is 25 centimeters. That is for a normal eye, right? So if you bring the object, let's say this is 25 centimeters, I can see it clearly. But when you bring it closer, then your eye lens will have to do more bending. So those lenses will have to press this lens to make it more thicker, right? So you will feel strained. Now see anything very close, your eyes will be strained because now the lens has to be pressed by the ciliary muscles. Okay, so you'll read that in biology. Okay, understand? Say yes or no.
Yes.
What did you understand?
The limitations of
Yes, the limitation of eye that it cannot see objects closer than 25 centimeters. There's a limitation. What if I want to see? Like,
microscope.
yes, then you have to use some optical aid, right? So it's not that you cannot bring it closer. So now if you're bringing it closer, you can do it with the help of some optical instrument, right? However, so this limitation can be removed. However, to be able to see, yes.
HOW.
However, okay. So it was correct, right? However, to be able to see objects closer than 25 centimeters, we need, what do we need? Microscope or magnifying glass. Microscope itself is magnifying glass or magnifying glass. Now recall the ray diagram where we get magnified image when the object is very close to the lens. When do we get a magnified upright image? When the object is very close to the lens, meaning when it is kept between focus and optical center. So that is in case of convex lens, right? Now see, this is a convex lens. Let's say this is the focus. When the object is kept between focus and O, right? The focus is here also. How the ray diagram is made? We'll pass the focus. And what about this? This AC? Where is the remote? Remote must be here, no? Somewhere. No? Sunday? AC बंद करना था. Now are these rays parallel or diverging? They are diverging, right? They are diverging because this is diverging, right? So the diverging ray should be extended backward, and therefore this will meet somewhere. Okay. So this AB appears A dash B dash. Right? Now, so where is it formed? The image is formed at D now. Okay. So now with the help of magnifying glass, we can bring the object closer and increase the visual angle. Right? Because now the eye is kept very close. Have you seen? When we see the fine print, we keep our eye very close, right? So that's what we do. So the visual angle is further increased because the object now we can bring it closer with the help of optical aid, such as magnifying glass. Is that clear? Now imagine if the same object was kept here, what will be visual angle?
Diminished.
No, diminishing. If the object was kept here, its visual angle will be, this is the visual angle. It will be very small. But now look here at this angle. When the object is closer, the angle increases. Correct? Okay. So in your book, this diagram is given. So don't draw the green part. See, this diagram is given. So the green part is for the object, the original object. So if the original object was at D, you wouldn't see it clearly, let us say. But when it is brought closer with the help of a magnifying glass, now this object appears this big. The small object appears to you this big with the help of the magnifying glass. Is it clear? Is the ray diagram clear now? Yeah. So now, what is the magnification of the microscope? So magnifying power is defined as of microscope. This is not microscope, it is simple microscope. What is the other microscope?
Compound microscope.
So it's not compound, it is the magnifying glass is just a simple microscope. Simple microscope. Is given as 1 plus dy. Okay, what is d here?
So she didn't understand the green part.
Green part is, suppose you don't have the lens. This part, you don't have the lens, right? So if the object is far away, right? So it appears, how does it appear? It appears smaller if it is far away, right? Now for a normal eye, anyway you cannot take the object closer than 25 cm. Now I am keeping the object AB at 25 cm, right? So now the angle is increased. If I want to increase the angle further, so I'll have to keep the object somewhere here. But for a normal eye, we cannot do it without the help of magnifying glass. Okay, so what this is shown is this situation, because if without glass, if you try to bring it closer, my eyes will start paining and I will not see the object clearly. So to see the object clearly, because there could be some fonts, like I said, some fonts are so small that I can't read it only, even with my good eye. Okay, so medicine pe hota hai, very fine prints are there. Then you need a lens to see it. Okay, so it is that situation. The object is so small that even with your normal eye, you need some aid to see that. Is that clear? You should have explained what she did not understand. Okay, fine. Is everybody with me now on this? Okay. So this is the formula you just remember. The derivation is in higher standard. Okay. What is D? V is 25. This least distance of resting point. F is the focal length of the lens. Is that clear? So this is all in okay, that's it. So magnifying power of simple microscope is defined like this, and then there is something called as magnification. What is magnification?
When the size of the image is increased.
Yes, so it is size of image versus size of. Okay, for a lens it is given as V by U. For mirror it is minus V by U. You have already done it, right? Correct? For mirror it is minus V by U, but for lens it is V by U. Okay, so these formulas you just remember. Okay. Now there are, so magnification, then there is a lens formula also. What is the lens formula? Can I erase this side? Have you written it down? You want to write it? So you have to do it quickly. You can leave this part. Do you want to write it?
No.
Because I have drawn it from my side. You don't need to write it. You start from limitation of y. Skip this part. Okay? Here also you can skip the green part. Okay, you can skip the green part, although in the book it is given, but without green part also you can do. closer than 25 centimeter cannot be seen clearly by normal eye. It will look blurry. Blurry. How did people manage in old times without glasses? They did not have television or mobile screen back then. The eyes were strong. How they would have managed their identities? No photographs, no ID cards now. You have today Aadhaar card and things like school ID.
Only paintings.
Paintings, yes. Yeah, they were painting, correct.
But that was also not perfectly accurate. It was not
Yes, and if you say, okay, recent photograph, last 6 months, what do you do? Yeah, paintings and sculptures, right?
sculptures.
Yeah. This is our second lecture on the topic, right? On this chapter, or third?
Third.
This third lecture today.
First day we did the lens, second day we did the ray diagrams, and third day.
Now you're done writing. All of you are done writing. Easy. Let me know once you're done writing. Completed? Okay. What happened? Everybody take a look at these diagrams. So now we are doing experiment to find the focal length of the given lens, right? So we have seen that every time we see a distant object from where the parallel rays come, it gets focused at the focal point, right? This is page number 86. So let's say we have kept some screen, right, at the end of the scale, right, or the zero of the scale is towards the screen, and then on that scale we are keeping this lens, which we are able to move towards and away from the screen, right? And what is the object? Object is like some tree outside your window. Some tree outside your window. So the light coming from that tree, right, will make the image of the tree upside down on the screen. Is it understood? Okay? So wherever, so when you keep shifting this lens, at one place you will get a crisp image, which will be real and inverted, because real image can be obtained on the screen. Understood? Instead of tree, it could be you also, anybody. Okay? So because you can see me, that means light reflected from me is reaching your eyes. Likewise, anything which you can see can be seen by this lens also, because lights are coming in all directions. Like he can see me, so can you. So light is, so from any object, light goes in, and anybody who is hanging on the roof can also see me. Right? So it's not that only two rays are going in all directions. Is that clear? Just for image formation, we take only two rays as an example. But there are infinite rays traveling in all directions from any object. So the rays coming from the object are obtained on the screen as an image. So now we know from the ray diagrams that we practice that any parallel ray, so this is a distant object, so we are assuming these are parallel rays. So where the parallel rays converge, they convert into focus. So this distance of the screen, the lens distance from the screen will be its focal length. Okay, so this is the rough estimate of focal length of a given convex lens. Clear? So you might be doing this experiment in your lab also, right? Then there is another experiment which is called auxiliary, what is called single pin method, one pin method. Okay, this is one pin method. So what do you have? There is an optical bench in your lab. So it is a calibrated scale on which you have various stands. On those stands you can fix plane mirror, lens, pin. Okay. So these are the stands which are movable on the optical bench. So optical bench is nothing but a plane surface which has a calibrated scale. So the positions of the stand can be marked, right? Like if this is at, so if the beginning is 0, the pin which is acting as an object is kept at 30 centimeter. Lens is kept at, what is it? 60 centimeter. and just behind the lens you have a plane mirror, right? So you see here the pin, right? You position your eyes here. You will position the mirror first, and the lens, and then the object. So this pin top, right, is sending rays over here, and though the image will be formed in the mirror. How is that? Inverted. Now that inverted image is object for this lens. So rays traveling here there is an image obtained on top of the pin. So what you see here dotted is the virtual image, okay, of the image formed in the mirror. So that's why.
So it will be erect.
No. It's upright down. So erect in the sense it is again passing through the concave lens, no? Convex lens. So it is inverted only. Okay, so you have the real object, and on top of it, you will feel the image in your eye, which is nothing but the image which was obtained in the plane mirror, which is now acting as object. This is the real object, and this is the image of the virtual object in the mirror. You understand? So this distance, okay, will be the focus now. So when you see, so what you are doing is, you have kept mirror and lenses together, and now you are shifting the object till you obtain an inverted image on top of it. So you have an image obtained like this on top of each other, and you are seeing. So now when you move your eyes, no, it should not happen like this. Both should move together. That's where the distance between the object and the lens will be focal length. So you would note x1, x2. So x2 minus x1, that will be focal length in this case. There is no auxiliary mirror method. Now, in this case, we had an horizontal optical bench. Now you have a stand on which you have fixed the object. You have kept the lens on top of a plane mirror. This is a plane mirror. Here the plane mirror was behind the lens. Now it is, plane mirror is at the bottom. The lens is kept above it. Now the object is here. Again you position your eye up. From here now you are seeing. Okay, so let's say this is the object, and now you are seeing from here. Then you will see the image here. Whatever is appearing in the mirror, okay? Now when you move your eye, they both should move together. Okay? So then the position where they both start moving together, the object and the image. So that average distance, right? So you have two distances. One is the distance from the plane mirror, and one is the distance from the top of the lens. So average of these two will give you the distance from the optical center. Okay? Here the distance is from the optical center only. This marking is from the center of the lens. Okay? But here you have to take the average distance. Is this clear? Have you all understood? So read it yourself, and this is how the focal length will be obtained. So where is the focal length? Where the image is obtained, right? That is what is focal length. So we get two distances. One is from the bottom of the lens and one from above the lens. And the optical center lies between the two lenses. So when you take the average, you will get the position of the optical center, from where you will get the image distance, which is focal length. Say yes, sir. Yes. So that I will get a good night's sleep. So the explanation of what is happening here, the ray diagram, etc., given over here. So there is an object, okay? These two rays go and then they return back. So the image is on top of it, inverted image. Okay? All right. So everybody has understood. Become experts. Chalo. So we still have some time left. 2 minutes. You know? Do we have some time left?
Yes.
Okay. So we are not going to cover anything extra. Just take a look. What is remaining now? Remaining is the sign convention and lens formula. So So we already did determination of focal length of convex lens, uses of lenses. Where do we use them? Spectacles, cameras, telescopes.
Where they do that specs and all.
Yeah, telescopes, projectors. Very good, very good. So already we have done the uses, right? So all those things. So diverging lens mostly in spectacles and projection. Are we using Galilean telescope? Two uses. No, projector में I think we are using convex lens.
In camera, it is upside down to make it upright.
So that is convex only, ना? Both lenses are convex. एक का उल्टा आता है तो उसको सीधा करने के लिए और एक convex lens.
Camera, what about camera?
Camera may have combination of concave, convex, but mostly it is convex only.
Convex.
Okay. All right. So I'll see you in the next class.
Thank you, sir.
Thank you.
Bye. अरे सब